Hello everyone. Today we are going to continue our tutorial with how to visualize data and preparing charts with these tools. The most useful tool is scatter function, which enables you to do the linear regression analysis. We can use bars and lines or pie charts, which is for percentages. The data you see is obtained from Turkish Institute of Statistics. This is energy input of a country. These are fossil fuels, and this is hydroelectric systems, and this is renewable energy and wastes. The data is go back to 1970s to 2012. From this data, we are going to prepare charts and try to analyze the data. To see it better, we need to use freeze pane function. Selecting this box B6, if I freeze pane from here, even if I slide the window, I will always see this, the top 5 column, wherever am I. There is no need to use this rows, so I'm going to hide them. The unit used for fuels are percentage. I'm going to convert them to energy, gigawatt hour. Let's copy this. I'm using here the new unit. The energy produced from the fuel is simply column B times the column of the fuel divided by 100, because this is percentage. Let's calculate this. This times this, but column B should be constant, so I'm going to use $sign. If I simply double click on the plus sign, I forgot to divide 100. If I just slide this, I'm going to use scatter plot to visualize the data. That's from insert. This is the scatter. This is just the empty panel. I'm going to select data. I can use data range or just simply this one. The name is this call. X value are always year, 1970 to 2012, and Y values are values of call. Holding shift button, I can select data, and this is call production. I'm going to use another one. Again, this time the series name is fuel. X values are 1970 to 12, and Y values are if I just hold from here and just slide it to the right, I can select all the other fossil fuel types. It will give me a bunch of data. I'll just remove this to see it better. Okay, from here we see that the fuel production is increasing for all cases. I can just use sum function here, and it will be just sum this. And if I just double click, and the orange one is sum. We prepared our chart. To have better visualization, we can use chart tools. From design, we can add chart elements. It is different in other Office versions, but in 2013 Office version, there is an add chart element option. Let's add axis titles, primary and vertical, and there is no need for grid lines, but grid line is the lines for smaller digits. We can have legends on bottom. In order to have some space for legend, I'm going to smaller the chart figure area. For axis title, I double click this part. This is energy produced. The unit, always use unit in here. And for axis title, this is just here, close here. Also, for better visualization, I just double click this part, and from the minimum value is 1970 and highest value is 2012. Here we have our chart, which gives us a huge data set of a page in just one figure. For discrete data, you can use the dots, scatter dots, or for continuous data you can just use these. There are lots of types of data actually. You can choose whatever you want. You can find out which is best for your case in home. Okay, let's solve an example. 2.36 from your book. This is a scanned question. The idea is there is some kind of exponential data which is equal to constant. It gives us the data of pressure and volume with the units of millimeter mercury and centimeter cube. From these data, we need to determine the constant C and K. I already put the data in here, P and V values. In order to do the calculation, first we need to linearize this function. For linearization method, I'm going to take ln of the equation, natural logarithm, which gives us this equation, and this time ln p is simply our y values and natural logarithm of volume is simply our x values. The slope will give us the minus k and the intercept is simply natural logarithm of constant. Let's calculate. This is our x values, natural logarithm of v, and this is our y values, natural logarithm of pressure. There is no unit for natural logarithm. Yes. ln is formula for natural logarithm. Yep. If I just use scatter function for this, scatter, select data, add. Okay, x values are ln volume and y values are natural logarithm of pressure, just like in this function. Okay, here we have this graph. If I just use a trend line, there is a regression analysis. If I right click to a dot, there is an add trend line. With this add trend line, I can use any type of this. If I just use linear and display r square, oh, it's r square equals 1. It means that there is no error. It's perfect fit. There is no need for interception, but we can use I can use exponential, logarithmic or polynomial fits. Obviously for 6 dots, if I use 5th order polynomial, it will give us also a perfect fit, but since r square is already 1 for linear regression, I can use linear 1. We can use forecast for forward and backward periods by this, but there is no need for this. Simply we have the equation for trend line. From this equation, the intercept is 12 point. Let me give intercept is 12.736, and slope is minus 1.573. What we know is from this equation, slope is minus k and intercept is natural logarithm of c. Therefore, if I take exponential of intercept, I can obtain c values and k values. C is exponential of this, and k is simply minus value of this. I have the solution for this question. For another question, I'll try to solve 2.40. This time I have an equation like this, and I have t and c values. Still, I need to linearize this equation. In order to make the linearization, if c equals to 1 over a plus bt, if I use the 1 over c function, it equals to a plus bt, and it looks like a linear plot. If I use x values as t and y values of 1 over c, slope will be equal to b and intercept will be equal to a. Let's make this calculation. 1 over c. Have a unit of liter per gram, and just simply equals 1 over B17. If I just drag this function, it will give me the data. Again, I'm going to use a scatter function. Select data. The x values are t and y values are 1 over c. Insert axis title, which is 1 over c, liter per gram, and this is just time, hour. If I use linear regression tool, right click, add trend line. From add trend line, okay, if I just use polynomial one, obviously r square will increase. It has to be linear to find b and intercept the a. R square is a little lower than the next one, but still acceptable. Points above 0.95 should be acceptable, counted as acceptable. As I said before, slope will equal to be b and intercept is a. And b value is simply, yep, this is our result for this question. This is the end of our problem solving section. Thank you for watching.